Hello everyone. It's a great honor for me to apply for Women Researcher Award, Science Father and International Young Scientist Awards, which each encourage the researchers. I will talk about our research on UP-POPs pollution control in the industrial thermal processes. I will talk in four parts. First, unintentionally produced persistent organic pollutants. Unintentionally produced persistent organic, which is called UP-POPs, are not man-made or produced intentionally, but are created when other chemicals or products are made, such as solid wastes, incineration, iron ore sintering, and secondary metallurgy. These industrial thermal processes are the key areas of priority control of dioxin emissions. The Stockholm Convention on Persistent Organic Pollutants, signed in 2001, include dioxins among the first 12 kinds of POPs that need to be reduced and controlled. UP-POPs have four qualities, so development of dioxin control technology is a major need for China's implementation. Dioxins emission. Dioxins include PCDDs, PCDFs, and coplanar PCBs. Total emission from industry is about 10 kg TQ in China. This is a table of dioxin emission of industries of China. From this table, we can see about 60% of total emissions in waste incineration industry, iron and steel industry, and secondary metallurgy. Dioxins formation and inhibition. This is the setup of our experiment. The products have to go through a series of pretreatment and finally analyzed by GC&S. The formation of POPs have two maximum temperature range of 300 centigrade degree and 450 centigrade degree. In the thermal treatment of flash, carbon is not fully oxidized at low temperature. Partially oxidized carbon is converted to substances which can be oxidized at high temperatures. Effect of copper species on formation of chlorobenzene and PCBs followed order shows on this slide. Copper chloride shows the best formation activity. For PCDD, PCDFs, an increase of copper ratio in the copper-iron catalysis system led to the homolog distribution pattern moving toward lower chlorinated compounds. The proportion of higher chlorinated PCDDs, PCDFs decreased, and the more lower chlorinated PCDD, PCDFs were generated. PCBs and chlorobenzenes also exhibited a similar isothermal distribution. Deconvolution of copper 2P showed two obvious peaks. The result indicated the generation of copper's chloride in the thermal treatment of fly ash. The decon reaction was promoted and more chlorine was produced. Native carbon was chlorinated and oxidized to form chlorobenzene and PCBs. PCDD, PCDFs were synthesized by hot cell attacked to chlorobenzene and PCBs, followed by HCl elimination. We selected inhibitors for pilot-scale sintering cup experiment. The equipment scale of Shougang Technology Research Institute is 100 kg per cup. Sulfur or nitrogen-based inhibitor was selected for lab-scale experiment for POPs inhibition. Thiourea showed a significant inhibition efficiency of PCB is 91%, attains an inhibition efficiency of chlorobenzene to 98%. The result of total chlorobenzene and PCBs shows that a larger molar ratio of sulfur and nitrogen to chlorine leads to a higher separation efficiency, so that thiourea with higher molar ratio has a higher separation efficiency than that of other inhibitors. Polymer inhibitors have inhibitory effect on chlorobenzene and PCB. The TUFR has the best inhibitory effect. The inhibition efficiency of chlorobenzene was 92% and the inhibition efficiency of PCB was 87%. The effect of different mass content of TUFR on chlorobenzene, PCB, and PCDDFs shows inhibition efficiency of 98, 98, and 99% in the lab-scale experiment. The pilot-scale experiment with the addition of 2% thiourea and TUFR, separation efficiencies of PCDDFs in flue gas decreased to 95% and 59%. Dioxin inhibition mechanism includes 4 parts. First, decomposition of product. Ammonia consumes a chlorine source and inhibits the chlorination of aromatic compounds. Second, decomposition product of sulfur or sulfur oxide reacted with the precursors. Third, the sulfur-containing decomposition products react with copper chloride, produce compounds with lower activity. The last is sulfur or nitrogen molecules have lone pair electrons, which can form stable compounds with transition metals such as copper. Dioxins decomposition. We developed novel transition metal loaded on activated carbon as catalysts to decompose PCBs. By comparison, we found that the catalyst activity prepared by ion exchange method was higher than that by impregnation method. By comparing the catalytic decomposition efficiency of 4 kinds of transition metals, nickel showed the highest decomposition activity. We developed novel transition metals loaded on gamma alumina and ZSM5 as catalysts to decompose PCDDs and PCDFs. Gamma alumina catalyst showed higher activity than that of ZSM5, and the decomposition efficiency of PCDF increased. Decomposition efficiency of nickel supported gamma alumina for dioxins was 96%. Decomposition pathways and reaction mechanism was illustrated by Zien's, EXAFS, and in situ XPS measurements. Metals are electron donors, while PCBs were stepwise dechlorinated as electron acceptors. DFT theoretical calculations show that the adsorption of chlorine in PCBs by bimetallic catalyst is stronger than monometallic catalyst, so as to improve the decomposition of PCBs. The reaction activity of chlorine on the benzene ring was related to the substitution position. The chlorination order is para position, metal position, author position, which in turn guides the design of the catalysts. Thanks for the members of my group. Also thanks for the fundings supported by BST, NSFC, and the MOST. Thank you for your attention.